So other big ideas, net area versus total area. Net area, like you mentioned, is sometimes called signed area. And net area or signed area, that's just the definite integral from A to B, f of x dx. Boom, done. No problem. Total area, that's the trickier one. That is where we have to reconsider whether it's positive or negative and strip the negative out so we get always positive areas. So that would be the integral from A to B of the absolute value of f of x dx. And the only way to do that is to pretty much find out when f of x is greater than 0 and when f of x is less than 0 and integrate those two parts separately, or three parts, or however many there are. So you don't actually get the cancellation you get in the net area. And so graphing calculators are super helpful for that. Sometimes we have to solve an equation for when it is 0 and check when it's positive and negative. Let's look at a simple example of this. Let's suppose we want to find net and total area for f of x equals 2x minus 1 on the interval from 0 to 4. So total area is the harder one, so let's do net area first. The net is just going to be the integral from 0 to 4 of 2x minus 1. And confident we can all do that without too much trouble. So I'm going to take a look at the net total area next. Total is the integral from 0 to 4 of the absolute value, 2x minus 1. And in order to do that, we got to figure out when it's 0, where it's positive, and where it's negative. Graphically, whip out our calculator. We did a sketch of this one earlier, so I'm just going to redraw over here. That has a y-intercept of -1 and the slope of 2. So that would be this right here. Up to 3, no, up to 4. I didn't leave myself quite enough room there. This is not quite to scale. At 4, we're going to get 7. At 0, we're going to get -1. So we have some negative area here. And then some positive area. So we just have to find them separately. So if we take 2x minus 1 and set it equal to 0, then we're going to get x as a half or 0.5, works kind of nice too. So it turns out two different integrals is fine. So for this one here, I would have to integrate from 0 to 0.5, 2x minus 1. Since that is going to give me a negative area, I got to remember to take the opposite of that. And then I can add on to that the integral from 0.5 to 4 of that same function. So the hard part here is figuring out where to break it and then which parts are positive and which parts are negative. Antiderivative is not bad. I would plug in with a calculator. This would be definitely a question I would give a calculator for. Double check where you transition from negative to positive or positive to negative. Questions on the setup for total versus net? Okay. Just going to leave that one there. The easy part is yet to be done. We did the hard part.